Hi everyone, my name's Stephen and this is DG STEM TV. Now, everybody say, let's do some science. Why is space black? That's a good question that covers a lot of science. If you looked at the sun directly in space, you'd be blinded. That's why astronauts have those gold visors on their spacesuits. Even down here on the surface, we often wear sunglasses on bright days. Let's make this big question small by asking first, well, why is it the daytime sky is blue down here on Earth? And the answer to that is a bit more simple. It's because light can bend. And if you don't believe me, just check this out. Hi! That's terrifying. These are just my glasses that I use to help see sometimes, and they do that by bending light. So light bends as it passes through different materials. It's gone from air to glass and back to air, and each time it's being distorted a little bit. And it just so happens that as light bends, sometimes it ends up scattering too. I think this calls for an experiment, don't you? This is a pretty simple experiment setup. We have a glass of water with a torch shining through it, to which we add some milk. Aside from it being very pretty, you can see how light is reflecting off each little bit of milk there, and that is scattering. And when we mix the milk into the water more evenly, the light scatters evenly as well. It almost looks like it's glowing now with this bright white light. And as we add more milk, we can see that while the light's still sort of scattering and emitting that light at the start, towards the end it's just purely reflecting off the milk, so it's not getting through. And eventually we reach a point where the light isn't scattering at all, it's just reflecting off the milk. And this is really similar to the way light from our sun scatters through the atmosphere. It just so happens that the blue part of the light from the sun scatters better. So we see a blue sky most of the time, until the sun gets low enough in the sky for other colours to scatter through as well. So, now we have a good understanding as to why the sky is blue, we can begin to talk about why the universe itself is so dark. After all, it's filled with stars. It would make a lot of sense if the night sky burned with this white hot light of the force of 1 billion suns, but it doesn't. And the reason for that is twofold. First off, the universe is massive and it's very, very old, but it's not infinitely old. And this means that there are stars out there, most likely, whose light hasn't reached us yet. Hasn't had time to get there. Because light, while really, really fast, isn't quite instantaneous. And then there's also the fact that the universe is always expanding and getting bigger. And as space expands, the distance light has to travel to be seen by us increases, and its energy therefore gets less, and that makes it dimmer and redder and harder to see. All this makes looking at and seeing and finding stars incredibly difficult, as well as aging them. And that's a job that falls partly down to the field of astrophotography, which is a really interesting specialty and takes a lot of work and a lot of knowledge. But we managed to have a chat with a certain knowledgeable person who agreed to tell us how it's done.
My name's Helena. I'm a 16-year-old astrophotographer and astronomer from Scotland. I first was interested in space maybe when I was about 10, and the primary school in Wigton, which I used to go to, asked me to do a school project. And it was about life on other planets. And then I got my first telescope when I was like 10. And then it really amazed me that from like my windowsill, I could see craters on the moon. It was a tiny telescope, like a little Celestron first scope, which I now can recommend to beginners, which is fantastic. But I used that to observe the moon for a little bit. And I kind of decided that I wanted to share my sort of journey with other people.
Helena's YouTube channel has amassed thousands of followers who all love her space content. But what does being an astrophotographer actually involve?
Space. It's basically taking your telescope out, taking your rig out into your cold and wet and dark back garden, in the middle of the night with your neighbours wondering what the heck's going on, and taking photos. After I started looking at the moon, I started looking at close by nebula and galaxies. So the first one I looked at was M45, and all I could see through the eyepiece was the magentas and the purples coming through from the nebula. But again, that amazed me that I could see that from my garden without even, it wasn't even taking any exposures, it was looking with my eyes, which is a lens that we take for granted, our own human eye. And I looked through it and I saw the colours and I was like, I'm seeing colours of this thing, which is light years away from us. You need to use what you've got, because I feel like people go out of their way and they're like, I need to buy this that costs £5,000. I'm like, but no, you don't. Like, people don't realize that the camera on a phone is called a CMOS camera, and the sensor that I use in my deep sky imaging camera is also a CMOS sensor. So people don't realize like the similarities. So you're picking up a CMOS sensor every day. That's what I use every day to shoot deep sky objects. And if you've got DSLR cameras or lenses if you do photography, so like for the likes of yourself that do photography, people don't know that they can use their DSLR cameras as imaging cameras. That's how I started. I started using those, and like telephoto lenses as well. I started using those quite early on, so people don't realize that they can optimize what they already have.
The CMOS sensor that Helena's mentioning is used literally everywhere. I'm pretty sure there's one in my DSLR here. But what is a sensor exactly? Well, it's a part of a camera that turns light into photographs, essentially. It's the center of the camera. In digital cameras, they are made of pixels, which individually sense and catalog light and color. In older analog cameras, or film cameras, they have film, which reacts to light. And this is very similar to that. So we're going to do a wee experiment with them, just to see how well it works. In the pack, you will find bits of paper like this, onto which you can lay whatever kind of subject you wish to capture. In this case, I've cut out some shapes to create my scene. You lay them down like so, and then you can pop this bit of glass, which is quite handy to keep things flat, on top. And then you simply leave them in bright sunlight. The instructions say to give it around 3 to 5 minutes, but I gave it a good 5 just to be sure, since we were in Scotland. And what happens is it reacts to the sunlight. There's a chemical transformation going on in the paper. And once you come back, take it away, you give it a rinse, and another chemical transformation takes place, which leaves you with this. And one of the really fun things about sandpaper is you can play with more 3D objects too. I grabbed a few of these safety pins to create something a little bit more experimental. See, this is my first attempt with the cutout. And then I did that again and I tried using cardboard, which actually didn't work quite as well. If you can see there, yeah. And that's partly because the shadow that the cardboard cast also made a difference. So you can, it's like a bleeding effect. You've got the actual white and then like a paler shade there. But it still looks really cool, I think. And then you have the experimental one, which is here. And I think this looks incredible. That's so cool. I love that. So why don't you have a go at that yourself? If you want, you can get these sandpapers for about £10. Make a great gift for a friend, or even for yourself if you want to put it on a list. Of course, the sensor in Helena's camera is a bit more sensitive and allows her a little more control over the sensor's exposure, or the amount of time the sensor is reacting to light, which enables her to take those detailed images of deep space objects.
When you're doing astrophotography, because it's dark, you
Mhm.
need long exposures. So it takes a while. The shutter is open, if you will, for like quite a while. So say maybe 3 minutes, 4 minutes. You can even do 20 minutes. I haven't got that good yet. So say I'll be waiting 3 minutes, and 3 minutes doesn't seem like a long time, but when you're out there, it feels like 3 hours. And when you see that image come through, the stars are around, the color is there, and you can see the whole image coming together, like what it's going to look like at the end after editing. It's the most satisfying thing. And that is when you get that like piece of excitement that comes into you that you literally can't describe. Like, I can't replicate that feeling in any of the other stuff that I've done. Like when that exposure comes through, that is it for me. That is what I want to feel.
And if you are looking to experience that sort of excitement for yourself, well, Helena has some tips on how to get started.
I always recommend to people that want to start astrophotography is to learn the way around the night sky first.
Right.
So if you've got a smartphone, get a free app. I use Skyview, and Skyview is great. And you hold your phone up in your garden at night, and it shows you where everything is in the sky. So start learning some of the main constellations first, maybe a couple of the bright star names, when the planets are rising, the moon phases, and then you're going to get a really good idea of where things are when.
But once you've got your head around where the stars are, what are the basic elements of an astrophotography setup? What do you need?
You're going to have the camera sensor on the back, a filter if you need one, but that's not like a main element that you would consider thinking about when you think of an astrophotography rig. You've got an equatorial mount on the bottom, which is quite a big and rugged piece of equipment. And what this does is, so the Earth is on an axis and it's going round, and the stars are moving. So you need something to compensate for this. So this German equatorial mount tracks the stars and compensates for the Earth's tilt, which keeps them like crystal clear and sharp. It's easy to explain, but it's really difficult to do. At the beginning, you have to align it with the North Star. And the North Star is called Polaris. And you have to do this so that the mount knows where it is. And when it's got that first point in the sky, it can tell from that where everything else is. And you basically turn these altitude and azimuth knobs right and left, up and down, until the star is in, say, 3 o'clock, the 3 o'clock position. And that way it knows where it is, where it's sitting, and where everything else is in the sky. Alternatives to that are star trackers, which are basically identical to equatorial mounts, but they're much, much smaller. They're like tripod size. And the third thing you can use is a tripod. No tracker at all. You just have to take really, really short exposures to avoid the stars trailing as they move through the night. Those are the three main mount types. Then you've got your telescope, which can be easily traded out for a camera lens, even a 50mm for Milky Way, or a telephoto lens for doing deep space, and then you move up to a telescope. Camera on the back, this could be a DSLR camera, so one you use day to day. It can even be your smartphone that you hold up to the eyepiece, or it could be a dedicated astrophotography camera.
So you've got your first telescope, you've got your sensor, be that in a camera or an SLR, you've got your tripod or your equatorial mount or your star tracker, and you feel like you're ready to get going, but maybe you're feeling a little bit intimidated because, well, it's a big scary field to just dive into. But fear not, because like most scientific fields, astrophotography has an amazing supportive community, as Helena's just about to tell us.
The astro community is like no other. Like, I came into the hobby with nothing, and I got these people. Like, I started posting these videos, and these amazing people started commenting, getting in touch, emailing me with, hey, you could be doing this to make this easier for yourself, or hey, do you want to work on this together, because I'm struggling on this too. And those more experienced got in contact, and I'm like, kind of honoured to be one of those people now that can help beginners, because I never thought I'd be in the position to be able to help other people, even though I'm still learning so much myself. But the community is amazing. I'm actually part of a women in astronomy group called Stella, and Stella stands for Striving to Engage Ladies in Astrophotography. And we're basically, it's like a safe space, and we are promoting more women in science, because when I came in to the hobby, I noticed that there weren't a lot of girls in the hobby. So I came in and I started the hobby, and I found this group quite late on. It was like last June, and sort of in the middle of the period when I'd started Deep Sky, and it really just lifted me up. And it's like sort of an empowerment group. We meet every week and we talk about the most amazing things. We like the same things, and we don't just talk about astrophotography. We get together and talk about what we had for dinner last night. We're just there for each other. But I think not even just Stella, like the whole astro community, when I started Instagram as well, like that's whole new level, the astrophotography community and Instagram. And it's very interlinked with the YouTube one as well. So I feel like it's a very nice position to come into astrophotography and have all these people to talk to. It's really reassuring as well.
A massive thanks to Helena for speaking to us. She is a true inspiration and her work is absolutely amazing. If you want to check out her YouTube and Instagram, I recommend you click the links below. Thanks for coming along with us. We've been everywhere from back gardens to the furthest depths of space today. It's been quite the journey. If you want to see more, don't forget to like and subscribe, and you can check out our other videos as well. And also you can join us on our Slack channel, where we chat about the episodes, about the experiments within, and generally help each other out with all things science. We'll leave you with a selection of some of our favourite photographs taken by Helena in the bonny land of Dumfries and Galloway. Enjoy.